Have you ever gazed up at the night sky and wondered about the mysteries it holds? Among the countless celestial bodies, there's one that has intrigued scientists and space enthusiasts alike for decades: Pluto. Once known as the ninth planet of our solar system, it was reclassified as a dwarf planet in 2006. But does this make it any less fascinating? Absolutely not. Pluto, a distant icy world, is shrouded in mystery. Its remote location makes it a challenge for even the most powerful ground-based telescopes to reveal its secrets. But what if we could get a closer look? What if we could unravel the enigmas that Pluto holds? In 2006, NASA embarked on an ambitious mission to do just that. The New Horizons probe was launched with the aim of studying this far-flung world. But what did it find? Is Pluto as dormant and uneventful as we once thought? Or is there more to this dwarf planet than meets the eye? Stay tuned as we journey through space, time, and the icy landscapes of Pluto. Imagine embarking on a journey that spans billions of kilometers, crossing the vast expanse of our solar system to reach a destination that's been shrouded in mystery for decades. This was the mission of NASA's New Horizons probe. Launched in 2006, this spacecraft was destined for Pluto, with the goal of shedding light on the enigmatic dwarf planet. New Horizons' journey was not a short one. It took 9 long years for the probe to reach its destination, but the wait was worth it. As New Horizons approached Pluto, it began to capture images and data that would forever change our understanding of this distant world. The probe didn't stay long, but the data it collected during its flyby is still being analyzed by scientists today. And what they're finding is nothing short of astonishing. Pluto, it seems, is not the dormant, inactive world we once thought it was. Instead, new studies suggest that Pluto is geologically active. Yes, you heard that right. This distant, icy world, once considered the 9th planet of our solar system, is showing signs of geological activity. But what does this mean? What kind of activity are we talking about? And what could it tell us about Pluto and its place in our solar system? As we delve deeper into the data from New Horizons, we're beginning to piece together a picture of a world that's far more dynamic and intriguing than we ever imagined. So, let's take a closer look at these discoveries and what they mean for our understanding of Pluto. Pluto, a world far removed from the warmth of the sun, is a realm of ice. Its surface, a frozen expanse of nitrogen and carbon monoxide ices, presents a stark contrast to the rocky landscapes we're familiar with on Earth. But it's not just the composition of Pluto's surface that's intriguing. It's also what's missing. Unlike many celestial bodies in our solar system, Pluto's surface is notably devoid of impact craters. These telltale signs of asteroid or meteor impacts, which are common on planets and moons, are conspicuously absent on large parts of Pluto. Additionally, there's no evidence of plate tectonics activity, the geological phenomenon responsible for mountain formation on Earth. So, what's going on? Scientists believe that the lack of craters and tectonic activity points to recent geological disturbances on Pluto. And when we say recent, we're talking in cosmic terms, within the last 2 billion years or so. The most likely cause of these disturbances? Volcanic eruptions. But these aren't your typical volcanoes spewing molten rock. These are ice volcanoes, or cryovolcanoes, a phenomenon unique to icy worlds like Pluto. 2 significant volcanic features dominate Pluto's icy landscape: Wright Mons and Picard Mons. These aren't just bumps on the surface, they're towering structures that rise high above the surrounding terrain. Wright Mons, with a width of about 150 kilometers and a height of nearly 5 kilometers, features a central depression almost 50 kilometers across. Picard Mons, even larger, stretches about 225 kilometers wide and reaches nearly 7 kilometers into the sky. To put these features into perspective, consider this. Despite Pluto's diameter being just 1/6 of Earth's, the volume of these cryovolcanoes is similar to that of Mauna Loa, one of the largest volcanoes on our planet. These icy giants stand as testament to the dynamic and active geological processes at work on Pluto, challenging our perceptions of this distant dwarf planet. Pluto's surface is not just a barren expanse of ice, it's home to some truly unique geographical features, one of the most striking being the Sputnik Planitia ice sheet. This vast ice sheet, part of the larger heart-shaped feature visible on Pluto's surface, is an ancient impact basin, nearly 1,000 kilometers wide. But it's not just its size that's impressive. The Sputnik Planitia ice sheet is characterized by folds and rises that appear like wrinkles over a smooth cover of ice, hinting at geological activity beneath the surface. Upon closer examination, scientists have identified several volcanic domes within this region. These domes, they speculate, could be the result of multiple eruption sites located near each other. The material ejected during these cryovolcanic eruptions may have coated the entire region with layers of ice, creating the unique terrain we see today. But for these eruptions to occur, there needs to be a heat source. On Earth, volcanic activity is driven by heat from radioactive decay within the planet's interior. In some cases, heat can also be generated by the gravitational interaction with massive neighboring objects. But neither of these scenarios seems likely for Pluto. Its neighbors aren't massive enough to generate significant tidal forces, and there isn't enough rocky material in Pluto's core to produce heat through radioactivity. So, where does the heat come from? Scientists believe that the answer may lie beneath Pluto's icy crust. The theory is that a deep water ocean, trapped beneath the ice, could be providing the necessary heat. This isn't as far-fetched as it might sound. Other icy bodies in our solar system, such as Saturn's moon Enceladus and Jupiter's moon Europa, are known to harbor such oceans. Could Pluto be another member of this exclusive club? As we continue to analyze the data from New Horizons, we're getting closer to answering these questions. And with each new discovery, we're gaining a deeper understanding of Pluto, a world that continues to surprise and fascinate us. As we delve deeper into the mysteries of Pluto, it's worth drawing comparisons with other icy bodies in our solar system. Take Saturn's moon Enceladus and Jupiter's moon Europa, for instance. Like Pluto, these moons are known to harbor deep water oceans beneath their icy crusts. Enceladus even shows evidence of regular cryovolcanism, spewing icy material out into space and replenishing one of Saturn's rings. However, Pluto stands out in one significant aspect: its icy volcanoes. While cryovolcanism has been observed on other icy bodies, the presence of large, sprawling fields of icy volcanoes on Pluto is unique. These features, which appear to have formed through multiple eruption sites, have not been observed anywhere else in the solar system. This unique characteristic sets Pluto apart and adds another layer to the intrigue surrounding this dwarf planet. But as we draw these conclusions, it's important to acknowledge the limitations of our current understanding. The New Horizons mission, while groundbreaking, only offered a brief glimpse of Pluto. The probe made a flyby, observing the region for just one day. As such, there's still much we don't know about this distant world. Is cryovolcanism still active on Pluto? Are the exotic ice volcanoes dormant, or do they continue to reshape the planet's surface? And what about the possibility of a liquid ocean beneath the icy crust? If such an ocean exists, it could have far-reaching implications, potentially even hinting at the existence of life. As we continue to analyze the data from New Horizons and look forward to future missions, we can only speculate. But one thing is certain: Pluto, once thought to be a cold, unchanging world, is proving to be a hotbed of geological activity and scientific discovery. As we continue our exploration of the cosmos, who knows what other surprises await us on this distant, icy world? If you've enjoyed this journey through the icy landscapes of Pluto and want to continue exploring the mysteries of our universe, don't forget to subscribe to Mission Universe.